Okay, welcome. In this video, we're going to go over geometric probability. So this is probability that's based on areas. So you have to find the favorable area, remember the area that you want, and it's going to be out of the total area. So I think the easiest thing to do is just to find the total area first, and then decide what your favorable area is going to be. So our first example here, it says if a dart randomly hits the board, what is the probability that it will hit in region 2? So region 2 is our favorable area, and then we need to do it out of the total. Now, the total area, this is a rectangle, so we need this length here and that length there. So what I'm going to do is I'm going to add, because see, this section right here is 10 and the other section is 30. So the whole length of that is 40. And then up here, we have 15 and 10, so the whole length of that is 25. So my total area, okay, is going to be 40 times 25, because this is a rectangle, so you got to find the area of a rectangle. So do 40 times 25, and you get 1,000. Okay, so that's your total. Now, region 2, okay, we're going to do region 2. So that's another rectangle. Okay, and this rectangle, it's 30 by 15. So we're going to do 30 times 15. And so you get 450. Okay, so we want the favorable out of the total. So we got 450 out of 1,000. Now, for geometric probability, okay, because we're going to have circles and other shapes and we're going to get some decimals, what I want you to do is express geometric probability as a percent right away. So take your fraction and turn it into a decimal and then multiply that by 100. So we'll do 450 divided by 1,000, okay, and you should get 0.45, and then multiply that by 100, and you'll end up with 45%. So for geometric probability, I want you to do these in terms of percents. So take the fraction, turn it into a decimal, and multiply that by 100, and you will get your percent. Okay, now the next kind of problem that you're going to have is landing in a shaded region. Okay, so the way that these are going to work, it's going to be your it's going to be a shaded part for the total. It's going to be the total area, and then you take away the unshaded part, so that gives you the shaded, okay, out of the total. So it's total minus the unshaded out of the total. Okay, so that's the usual formula that you're going to follow. So then you just look at the different shapes you have. Our total area, it's this square. So how do you find the area of a square? Well, it's like a rectangle. It's side times side. So in this case, 10 times 10. So our total area is 100. Okay, now we have the unshaded. The unshaded is the circle. Okay, so you gotta look up the formula for the area of a circle. Well, it's pi r squared. So pi times now r. Okay, here this circle goes from edge to edge. So we have the diameter. The diameter is 10. So the radius has to be 5, half of that. So r is 5. So times 5 squared. And I want you to leave this in terms of pi, so that you won't have big decimals. So this is going to be 5 squared, so it's 25 pi. You cannot forget the pi. If you forget the pi, your answer is going to be completely wrong. So do not forget to put that pi back on the end. Okay, so now we have the total, and then we have our unshaded, the circle. Remember, that's our unshaded. So now what we're going to do, because to get the shaded part, you're having the total, and you're taking out the unshaded part. And that leaves you with just the shaded part. So that's what we're doing on the top. So we have total, which is 100, minus our unshaded part, which is our 25 pi, out of our total, which is 100. Now what I want you to do, I want you to type this into the calculator exactly like this. So type that in your calculator exactly like that. Okay, and when you do that, you're going to get your decimal 0.2146 and all of that, right? Because on and on. And remember, to convert that to a percent, you just multiply by 100. So times 100. And so you'll get 21.4601, on and on and on. What I want you to do is just round this percent to the nearest tenth. So look at the 6. What happens to that 4? It bumps up. So we're going to get 21.5%. So just whenever you have all your area ones, just plug in the expression like this. Okay, especially when you have pi. Get that decimal, multiply it by 100, and then round it off to the nearest tenth. Okay, round that off to the nearest tenth. So that's how we're going to do our answers for geometric probability. So geometric probability, I want you to get me percents, because otherwise we're going to get weird decimals or weird fractions. So just do the percents. For this kind of problem, remember, it's your total minus the unshaded out of the total. And that's the setup that you're going to have to use. So you have to decide what kind of shape you have as the total, what kind of shape you have for the unshaded, and then you got to subtract and then plug in to this base formula. So we can go ahead, we can look at the assignment. Okay. For the first problem, it says they're tossing darts at this board, okay, and you want them to go into one of the holes. So they want to know what is the probability that it will go through the center, and then what will go through the lower left corner. So the center one, you have to read here. It says the diameter of the center hole is 8 inches. So all the way across is 8 inches. So it's a circle. So you got to do pi r squared for that circle. Okay. And same thing for the lower left one. They're both circles. Pi r squared. So you have to be careful. They've given you the diameter. You have to divide those by 2 in order to get your radius first. And then you also have to find the total of that dartboard. So in this one, you're doing the total minus the circle that they are asking you to find out of the total. So here, total minus whichever circle they want out of the total. Okay. Or hold on, I apologize. You're just doing the circle that you want out of the total. Sorry, had my mind in the shaded one. So this one, you're finding the area of the circle and you're doing it out of the total. That's it, much simpler. Okay. Now on these ones, this is where you have to do the subtracting. I'm sorry about that. It's a shaded area. So here you've got a square, okay, a big square, and then you're going to take away the smaller square, and you're going to do it out of the total of the big square. Okay, on this one, you've got a rectangle. You're going to take out that circle. You're going to do it out of the total rectangle. And you have to be careful and note on this one, the circle doesn't go all the way across this way, but does this way. So they've given you the diameter going like this. So your diameter is 6, so be careful, you got to get that radius. And then here, you've got these 2 circles. From edge to edge is 4. So each of these, the diameter is each going to be 2. So make sure you find those radii for that. And then here, number 5, you got to do the sector area. So remember, it's the arc out of 360 times pi r squared, and that's your shaded part. Okay, that's your shaded part. So on these ones, remember, it's the total minus the shaded out of the total. Total minus the unshaded out of the total. So total minus unshaded out of the total, and then that would give you the probability. Only thing on number 5 is just this one's going to be shaded out of total. Okay, so shaded out of the total for number 5. So that's it. That's all the setup that you really need for these kinds of problems. Just remember, you're looking for the favorable area out of the total area. So that's the concept with these ones.